Good afternoon, everyone. I hope you are doing well, staying healthy, you know, getting enough sleep, everything. So, first of all, we are going to finish what we started. Last class. Everyone has this, right? Okay. I also uploaded this on video. Right? So, as a recap, what we did in this worksheet, we constructed the mean variance frontier. So this entire curve is mean variance frontier. And the curve consists of an infinite number of portfolios, right? This is your risk measured in terms of standard deviation. This is your return from each portfolio. So this portfolio consists of only two securities. One is stock, another is bond. So this entire curve is mean variance frontier. Mean means the return, variance means in this case risk. Although we are using standard deviation, it is called mean variance, not mean standard deviation. Just a convention, you can say. And what is MVP? Does anyone remember? Yes, exactly. Minimum variance portfolio, right? And what does this mean? Minimum variance portfolio. How did we construct this portfolio? What was the objective and constraints?
Lowest amount of risk.
Exactly. We didn't care about returns, right? It is the leftmost. Okay. And starting with the MVP, going upwards, this frontier is called efficient frontier. Because the lower portion of this graph is not efficient. It is part of the mean variance frontier, but these portfolios are not efficient because for each portfolio on the lower portion of the curve, you can find another portfolio going perpendicularly, which will have a higher return at the same risk, right? So that's why only this upper portion of the curve is called efficient frontier. Now, this is an efficient frontier. If you are a risk, if you are a rational investor, you will choose one of these portfolios. But as you can see, these portfolios are different, right? In terms of the risk and return. So how do you, specifically a particular investor, choose a portfolio? Depends on your level of risk aversion. So that leads us to this optimal portfolio template, right? OP. Here, in the previous case, our objective function was minimize the risk. Here, objective function is maximize utility, right? And so minimize risk, of course, we minimized the standard deviation of portfolio. And because we used only two asset portfolio, asset means in this case stock and bond. Our calculation for the standard deviation of the portfolio was very simple. Simple in the sense we could write out this formula like this. It will grow exponentially if you include more. For example, if you include one more asset instead of two, you have three. What will happen? So there will be, so you have S, B, and there will be another one for a squared value. And then you will have two more terms like this, because correlation is only between two. So you have correlation between SB, you'll have one more for, let's say the third asset is C, you will have SB, BC, CS. So for each asset, it increased by how many terms here? 3, right? So it becomes very infeasible to solve this way. So that's why we are going to use matrix multiplication when we work on a larger portfolio. And fortunately, we can do that in Excel. So that is the formula we used in our EF template, isn't that right? When we calculated this standard deviation, right? And remember, when we calculated, this is a portfolio return, right? So this is a portfolio return. This is the sum product of the weights and the return of each asset, right? Now, and we already discussed in the previous class that these returns are based on log returns, right? So that's why we had to calculate this return using this formula, right? Alpha I plus half of sigma I squared, right? So this is the return for each asset. So that's why when you come here, you see this formula, right? And this log return and the standard deviation of log return is coming from our data worksheet, right? Okay, so you have log return, the standard deviation of log returns that gives you your logarithm of expected gross return. And then you use these returns and weights to calculate the portfolio return. And then you use these weights and there is standard deviation and the correlation in your risk formula, right? Okay. Now, in case of optimal portfolio, our objective function is maximize the utility. And this formula is this one, right? So our portfolio return minus risk aversion coefficient times portfolio standard deviation squared. We are subtracting by a lambda scaled value of standard deviation. Higher the value of lambda, utility is penalized by a larger amount because we need higher return. So the portfolio has to generate higher return to satisfy the investor with a higher risk aversion. Do you follow the logic? Yeah. So remember lambda, right? When I say lambda, I mean this one, right? So higher lambda means or represents level of risk aversion. What is risk aversion? You don't like risk, right? And if you're a rational investor, given risk-free and risk, same return, you will of course choose the risk-free. So now how do you measure risk? Because everyone has different sense of perception of risk. So there are many ways to quantify risk. One of them is lambda, represented by lambda. Higher the value of lambda, higher the level of risk aversion, meaning that person is more risk averse, does not like to take risk. Now, we factor this in our calculation of utility, right? Because optimal portfolio for one person, the definition of optimal portfolio, one person is different from the definition of optimal portfolio of another person because their risk aversion differs. And that is why we are subtracting the return G20 and we are subtracting the standard deviation because it is risk, but we are not subtracting the same standard deviation. We are subtracting by the scaled, lambda scale. What do I mean by lambda scale? Multiplied by lambda, right? So it will be, return will be penalized by a larger amount if you have a larger risk aversion. You guys see the logic? Okay, so that's why the portfolio has to generate higher return for the same level of risk for that investor with a higher risk aversion. So that is the logic, right? That is just one way of finding utility. There are different kinds of functions find utility. And we found out for each level of lambda, what should be the optimal portfolio, and then we plotted them against the efficient frontier, mean variance frontier. So this is our curve, and the curve, the tangent, the point at which the curve touches the efficient frontier, that is optimal portfolio. Okay. And I showed you as you change the number of your risk aversion coefficient, it changes. This point, tangent, moves around. So 11 is the highest level of risk aversion. But if we change it to, let's say 2, what do you think will happen? So this tangent point will move upward or further downward? So I'm decreasing the risk aversion. That means this person can take more risk. So we will go to more risk. So upward, right? So for example, if you type 2 here, it is going upward on the efficient frontier, right? Any questions so far? No? Okay. So actually, we'll do the same thing now for a 5-asset portfolio. You'll follow the same process except for the calculation of the portfolio risk. Because it is 5 asset, we have to use matrix multiplication. That is the only thing different. So I'll close this. Let's go to download these 2 files. So what we are going to do, we want to minimize equal to portfolio standard deviation. Now, I'm going to, because we have 5 assets, I'm going to use 0.2. So if you want to keep the template intact, and I suggest you do that, click here, choose without formatting. Now, these are our constraints. What does this constraint mean? W means weights, and this symbol is summation, isn't that right? So what does this mean? Do I need to make it bigger? So this constraint means no one knows.
Some of the point,
Some of the weights, right?
Yeah.
Yeah, these are the weights. The sum of the weights. What happened? Is it showing me the wrong? Okay. So you remember you need a formula here. You cannot just type 1. You have to type 1 here. This is the condition. Now this is your mu. So this is the return we want on the portfolio. So this. Now this needs to equal to, we have to solve for each of them. So let's say I want to solve for the first one. Or you can just directly type here if it is easy to remember because you typed here too. You can also type here 0.125. Now, short sales is allowed. So we don't need a constraint that this weight, each of them has to be greater than or equal to 0, right? Short selling is you're selling and getting the cash, right? And use that cash in your long position. So negative, that's why it means it is a short position. So short sales are allowed. So we don't need this constraint now. So we have to do for short sell allowed, short sales not allowed. Okay. Now let me calculate this one first. So let me bring alpha from data. So remember, these are the logarithmic returns. This is our alpha. And then I will just, because they line up properly, right? These line up correctly. What I will do, I'll pull down and then I'll pull across without formatting. Now, this is the formula I have to use, right? Formula. The logarithm of expected gross return. So equal to our alpha plus half times sigma squared.
Pull down and pull across.
And then pull down you mean this rows?
Yeah.
Yeah, pull down and then pull across. Yes. And then type this formula above and then pull across.
Where's the point five coming from?
Half.
Half.
Yeah.
Coming from.
So this is remember the formula?
Okay, okay.
Yeah.
0.5. Was 0.5 plus what?
0.5 times this sigma squared. Now, we'll calculate portfolio return. Go ahead and do that by yourself. Sum product, use sum product. Sum product of the weights and the returns, mu. Yeah, sum product of the weights and the returns, which are mu's. So this is the syntax for sum product. So this is our first array, comma, our second array. As simple as that, yeah. Okay. Now, the fun part, portfolio standard deviation. Enter equal SQRT square root, because we are going to calculate variance, comma, MULT, MULT, matrix multiplication.
MULT.
Right. So this is the way to remember. M means matrix, mult means multiplication. Okay. Open parent again. MULT again. Comma, open parenthesis. So the last MULT will do the first multiplication between our weights comma, we have to use covariance, not the correlation that we used previously. Covariance. So we'll go to data. These are our covariances. But remember, we have up to 5, right? So don't select everything, just this block.
Select everything.
Up to this, yes. And then close. So we did the first matrix multiplication. And we have the second one now, right? Second one will be between this product, comma, transpose of, so transposes inverse the matrix. Come back here, take the weights. Close, 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 3 times.
Transpose open bracket.
Yes, and then select these weights again. Press enter. Is that how much you got?
Yeah.
Very good.
I got the
Error.
yeah. 0968 867.
Okay, very good. So let me have a look. You also have the same issue?
Yeah.
And
2 times this.
no, yeah, so go ahead and delete the last part after transpose. You delete that too. Up to, before, yes. Now go ahead and select the weights again. Now close 3 times because you have opened 3 parentheses. What?
No.
Let me see, open it again. Mob, Apple 11, 11, data. Okay, so yeah, that. Can you show me page 17 and 21? Go back to data.
Sorry, I'm a little bit speedy. So how do you calculate this mean?
That looks right. Page 7. Can you go back?
This one. Can I see? Almost make.
Maybe.
Okay. Thank you.
So in your computer, what we have to do instead of pressing just enter, press Shift Control Enter. Okay. Go ahead and try to do that. Shift Control Enter. Work?
Yeah.
Okay. So do the same thing. Try Shift Control Enter. Okay, maybe there are a few other things. SQRT amount transpose. Oh, there should be. No, right. So in your case, it's max. So shift control is common, I believe, right?
Yeah.
Shift command enter.
It doesn't work. Yeah, it just.
Let's try back again. QRT.
I think I didn't hit the space at the one.
Oh, I see. Okay.
That may be it.
1, 2, 3.
Yeah, I
Okay.
didn't hit the
Okay, yeah.
space.
You don't have to press shift control. Just enter is good for you.
Okay.
Yeah, problem. Is everyone good? So that one is the only thing different here, actually. So I will just show you a couple of calculations so that you can do the homework. Okay, now go to data, solver, reset all.
That's the song. Okay. Reset all.
Yeah.
Okay.
Now, which cell should go here? It says objective.
Point 09. 0986.
So this one,
Yes.
yes, very good,
Me.
right?
Where's mine up there? I have it, but it's
Yeah.
not there. You just
Uh,
don't-
Equal to,
Like this?
yeah, now you're good, right?
Yeah.
Yeah. So which one should I choose? Max, mean, value of
Nice.
mean, right?
I mean,
Because we are still working on.
Oh, yeah.
It's giving me this. So. Drink into this, it's giving me this.
So if that happens, so yeah, this solver is not very user friendly. If that happens, just delete everything on that, inside that box, Yeah, backspace. Yeah, and now select the cell. Mhm. And then choose mid.
Giving me this.
Yeah, that's okay. Yeah, yeah, sometimes it happens, it includes the entire reference. So you see that name, it is the name of the worksheet.
Oh, okay, okay.
Yeah, so there are some nuisances. So, so mean, and what should go here?
It's the weights.
Yeah, weight, exactly. So one way to remember is variable, variables. Okay, now what is our next step? Anyone?
Add the constraints.
Add,
Yeah.
yeah, add constraints. So what is our constraints?
Objective must be single cell. It's giving me some.
What do you think, Zaba? What are the constraints? So constraints mean in this case, solver has to address this, right? These are the limitations. This is our first one, right? It has to be a fully invested portfolio. So the sums of the weights needs to equal to 1, right? Another one is we want a specific rate of return, right? Now we are working on the first one. Okay. So these are our constraints. And which sign should I select here?
Right.
Equal to, right? Equal to. So this, right? The weight is to equal to 1 and the return is to equal to the return we want. Push OK. Now short cell is allowed, right? So make sure you uncheck this. You should always actually uncheck this. Short cell is allowed, so we did not include this constraint. And uncheck this and solve.
And it's giving me problem.
Do you have a problem?
Yeah. Right, was it?
Okay, yeah, go now, you have to go back there.
To go there first.
Yeah.
So whenever you go, it shows this.
Yeah, so close it.
This one.
Now go back. Push OK. Let's see what happens. Okay, close again. And then close, close. Yeah, so close meaning from here. Let's see this one. Keep doing it. Sometimes it happens. Let's see. Okay, so I think the best way to do is just now delete the Excel file. Just, close the Excel file. See. What if we try to solve it? Okay. So. Okay, this is the only way forward. So it's always a good idea not close all the browsers. It affects with the performance with your laptop, right? So go ahead and open that Excel file where you have saved it.
Yes.
Okay, go ahead, open this. Let's see how much you have saved. See. Nothing has been saved. What is the time? 6:28. Let's try this one. Yes, so now what we are going to do. Go to data, solver, now try, but first reset everything. Okay. There you go, yeah. It's good. Yeah. And then sign is equal to.
These two.
Okay. Now unmark. Yeah, I'll check this and solve. Okay. Do you get the same number as I did? Is everyone good?
I got 0.1.
Yeah, okay. 1 second. Once, six. Greater than that value, then no, you don't need this one. You have to use this one. Now you from here. Yeah, so we're also go ahead and reset everything. I'll show you reset here. Okay. So. Okay. Yeah. Yeah, we should. Is it the same number? Yeah. Okay. So now what you do is copy this. Okay. And go ahead and calculate the return again here.
Paste as number. Just paste as number.
Yeah, it's just numbers, yeah. make sure you lock the returns so that we can pull down.
Some products. This one first, then this one.
Yeah.
Some products of this one first, and this.
It doesn't matter, order doesn't matter for
Okay,
some product, yeah,
okay.
for some product, for others it matters,
Okay.
yeah. And then you know what you have to do here. You have to calculate this. So equal to SQRT. Open, amount, open, amount. These are our weights, comma. Go to data. These are our covariances, but now we have to lock it because we want to pull down. Comma. Transpose. The weights again. Close, close, close.
More. We built it after the M12, MQ12 data.
Yes, sir.
Yeah.
Sorry,
No,
my
no problem.
computer had a little bit issues, so I'm behind, so.
Okay,
Can you
let-
tell
yeah,
me
sure.
what happened with this?
Let's see. Okay. Can you type Shift Control Enter? There you go. So in your laptop, you have to use Shift Control Enter for this function.
Okay.
Yeah.
I got it.
Other laptops are just Enter is good.
Okay.
Okay,
Yeah,
yeah.
thank you.
No problem. Is everyone good?
This one more time.
One more time?
Yeah, I'm good.
You're good?
Transpose. Transpose. Are you taking this one or this? Transpose.
Which one?
I'm trying to do the other one, the second one, but maybe this one's wrong.
Let's see. Two volt. Yeah, that's all.
Oh, wait, there's one too many here. This one.
We have. You have too many?
Yeah. I think. Yeah, no.
Oh, I said, okay, very good, yeah. You had one extra parenthesis.
Yeah, one extra. Which one do we need a lock on,
You need to lock on the covariances. So.
yeah, I had, but on the other one, the previous one?
For the other email first.
Yeah.
Yeah, this, everything. I can show you.
Go change that.
I had the other way around, okay.
Yeah, so this one. Oh, no. Now, I will not bother you too much, but let's do this. Go ahead and solve for the next return. Find out the weights. Try to remember what are the steps you have to follow now. And then I'll give you the other numbers. So we used this, right?
Mhm.
Now I want you to find out the weights for this portfolio, meaning the return has to be 10%. Everything else remains the same. So what is your step? What will you do? Go ahead.
We need to go to this one first.
You mean in this cell?
Yeah, and put the 10% there.
Exactly. Go ahead and do that. Yeah, just type 0.1
Mhm.
and solver, solve.
Mhm. So. I'm going to solve, we reset everything.
No, you don't have to reset. Yeah, don't reset. Yeah, just solve.
The mean now is okay. 0.1.
How much did you get?
The mean for the objective. And something like that.
So did you get these numbers?
Yeah, 0.1007 for the mean. Yeah, I got 0.48, okay,
Yeah, okay. So you know what you have to do. Copy this,
okay. Yeah, okay.
paste. And then let's go ahead and pull down up to all this without formatting. Now, what I'm going to do, I'll copy paste some numbers here. You don't have to enter this so many numbers. Now, so you don't have to enter these numbers. But what I want you to do is I will so what I want you to do is find out the weights for minimum variance portfolio. So let's go to solver. Reset, actually not reset. Let's just delete these constraints. No, sorry. We just have to add one more constraint, right? Yeah. So I was thinking so many ways of,
So do we have to have all the number you just copy?
so I copied from my solution.
Yeah, so we don't have all of them, right?
You don't need that, yeah.
Okay,
Yeah, I'm just saving you some energy here.
I see.
Yeah. So what I'll do, I'll upload the completed Excel later on. Okay, but I want you to
Yeah.
do what I'm doing. So, can you tell me what changes I have to make to find out the minimum variance portfolio? So far, our constraints had that we want a specific rate of return, right? And we also want the portfolio to be fully invested. So that means some of the weights needs to equal to 1. Do we need all these 2 constraints for our minimum variance portfolio? What do you care about in our minimum variance portfolio? Do you care about return?
Risk, right?
Only risk, right? So we don't care about return, right? That's why you also don't see any return, right? On that table. It is just written MVP. So what we are going to do, we are going to delete this, include only the weight constraint. Delete this constraint. So you have to push on here and then delete. Now add only this one. And push OK. So remember the difference between the others and the minimum variance. Push OK. And solve. Now the solution. Okay. Is that how much you got?
Yeah.
Perfect. Control C. Paste as values.
So for the portfolio, we don't need a portfolio. Portfolio value for us to solve the MVP,
We don't need what? Sorry, the return?
then the portfolio value.
This one you mean?
Like this. I've just gotten the 0.10. The portfolio is on the second line.
The second
The
line?
portfolio over there. The portfolio at the extreme end.
Oh, here?
Yeah,
Yeah.
yeah, so I just got the 0.1.
Where?
0.00.
On this line?
Yeah, on that line, yeah. The second. This one. Just got this. So we don't need this one to create this one?
Just drag it down.
Yeah, you can just drag down. Yeah, drag down the entire thing up to this. Yeah,
Oh, okay.
yeah,
I did the formula, that's,
yeah.
I just did, I did the formula, so.
I see. So what you can do, because you have locked cells
Mhm.
in the first 2 cells, so go ahead,
Just
go to the first 2 cells. Highlight the first 2 cells, yeah. And then just pull down. Up to the last one. The very last, yeah. There you go. And then from there, choose. Without formatting, yeah.
the formula.
Now. Did you solve for the minimum variance portfolio? So go solve for the minimum variance portfolio and then copy those weights on the MVP line.
Delete this one.
You have to delete from here. And just the first constraint, which is the sum of the weights.
This one.
Yeah, there you go. That needs to equal to just one, just the first one, not this one, the next cell. Yeah, equal to,
This one.
there you go. Yeah, push OK.
And solve.
And then solve. Push OK. Did you get the same numbers?
0.1, yeah.
Okay,
Yeah,
now go ahead and copy
just
paste.
Copy after.
Now, just to explain a little bit. So these portfolios are. Can anyone say what is this portfolio? The intersection of this and this. What does one mean?
Fully corporate bonds.
Exactly. Fully corporate bond, 100% allocation in corporate bond, right?
Mm.
Similarly, you have one here.
Okay.
Completely S&P 500,
Okay.
right?
Mm.
And this MBB just coming from this MBB, right? So this is the same thing we did for our previous problem. Now, now what I want you guys to do, come here. Now short sell is not allowed, okay? So go to solver. Reset. So our objective function doesn't change. Our variables don't change. But our constraint, now, these two, we need one more now, which is these weights need to be greater than equal to, we can type directly 0 here, or we could have typed 0 here and made a cell reference to that one. Push OK. So that means weights cannot be negative. So short sales are not allowed. Did everyone follow?
Yeah.
Java, you were good?
Yeah, I mean, I messed up before.
So if you messed up in the other table, continue here. So these are separate, okay? So try to do that one. Now push OK. And go ahead and uncheck this. And then solve. Okay.
Adding the constraint, should I add both the two constraints? Adding the constraint.
Yeah, you need the constraints.
Oh,
Yeah, you need one additional constraint, which is the weights need to be greater than or equal to 0. So that is what it means by short selling is allowed. Remember the idea of short selling, right? You have $100 million only. That is your money you can invest. But you are so excited or confident about the particular stock that you want to invest more than you have. So what do? One option is you can borrow a stock, another stock, sell. That will be selling, short selling stock, right? And that is a negative because if the shares you shorted increase, you will lose money. So that is that negative accounts for. Or another way, you can just borrow money, right? So, but eventually you have to pay off with interest. You borrow money, use that money in your long portfolio, a long side of the portfolio. So that is how short selling works. Does everyone have this? Okay. Edward, you're good?
yeah.
Yes. So go ahead and solve and see if you get these numbers.
So
This is, we solve for 10%, right?
Yeah.
So I'll just copy paste here. And then we can copy paste these two formulas from here. Paste as formulas. Actually. was here. And then pull down. Without formatting. Now, what I want you guys to do is solve for this first one. See how much you get. So all you have to do, type. Fine. And solve. Oh, sorry, not here. I messed up. Sound predict. This. Of this. This is the formula, right? I have to change
Yeah.
here. 0.125. Now solve. So you should get these numbers. So what I want you to do now, go ahead and solve for MVP. Minimum variance portfolio.
And so that.
So show me the solver.
This one.
So go ahead and minimize. Okay, you start just getting switch. And then P 1415, J 1415. Okay, now go ahead and solve. Okay, you got the same numbers, right? Yeah, yeah, post, copy paste. Mhm. Yeah, you don't have to select the entire, just one is good. Yeah, this first cell is good. As values. And then copy the formula, this mu and risk. From this gives us. Yeah.
Copy.
Yeah. So Control C, you can press Control C to copy to. And then Control V is for pasting.
Then I can just paste it here.
You can paste here, but go ahead and paste in the first row. Yeah,
This one.
yeah. Right click, right, okay. Yeah, that should work, but select without formatting. So go ahead and select the formula option FX. Okay, that's there. Now pull down this formula
To the very end.
to the very end. Without formatting. Okay, now solve for MVP. How much did you guys get? What was the return for MVP?
0.03.
0.0337.
Yeah,
Okay, and the risk?
0.00849.
Exactly. So. Solver. We have two. I will delete the first constraints. And then include only this. I will include this one equal to that one. Okay. This one I changed by mistake, so this should not change. So in case of MVP, what we do? We remove this constraint, right? We don't care about returns. That's why we have only this constraint here. And because short selling is not allowed, we have to include this constraint. Is everyone good? So solve. Okay. Control C. And you'll just paste here. Okay. Now, what I'm going to do is actually come to this worksheet. Okay. So this is optimal, right? So what, let me think. I will upload the complete Excel file for you and then I'll make changes there.
This one. This one's coming. This one.
longer. Okay, so this is the Excel file. Go ahead and download this. Excuse me. Now, I have intentionally deleted few things. I want to show you which are new. So let's go to this one. 5 asset efficient frontier completed. Okay. So you'll complete this, of course, like I showed you. Now, how to chart the efficient frontier? So you will take all of this. So you will highlight all of this. Insert recommended chart and let's select this one and we'll make changes. So this is not what we want. Is everyone good so far? Okay, now we are going to select data. So what Excel does by default, it plots the first column on the x-axis, second column on the y-axis. But in our case, it is the other way. We want this mu to be on the y-axis. So what we are going to do, we are going to edit. Now, this is the x-axis value, right? So go to this box, you can press tab on your keyboard. So that should highlight everything and delete. It will clean up. Now, on the x-axis, I want to plot this. So highlight this. Tab again, that should go to the next box, delete. Highlight this and push OK. So you should see something like this now. Doesn't look correct. Let me see what happened. Don't do anything yet. Let me figure out what happened here. So actually select only these. Maybe, yeah, so select only these. Okay. And then recommended chart, choose this one because we don't see another better chart. Okay, and then select data, edit, tab, change. Okay, I should have moved this. I should have moved this here. Now select data, edit, tab. This should be our x-axis. Next tab, this should be our y-axis. Okay.
Can you do slowly again?
Yeah. So highlight these two columns. Now go to insert. Maybe let me try. Do I have a better option here? No.
Oh, okay.
I can probably directly also go here. Sometimes if you go to recommended charts, it gives you the correct chart. Excel can read you, can predict what you want. So that's why I go to recommended charts. Maybe all charts. Scatter, no. Okay. So yeah, let's go to recommended chart, choose the first one, push OK. Is everyone good so far?
Yeah.
Okay. Now, move this.
Good, good.
Move this side. Now select data. What we are going to do here is swap the x and y axis values, right? Because x by default plots the first one on the x-axis, second one on the y-axis. But in our case, we want this one to be the x-axis. So edit, go to this box. So one easy way to do this is just press tab and delete whatever you have inside. And highlight this x-axis values. Press tab, delete, highlight the y-axis values and push OK. Okay. Worked?
Yeah.
Did it work for everyone? Okay, so this is our frontier.
Select data,
Yeah, select data,
Yeah.
edit,
edit, okay.
and you in your x-axis value, you will include this. In your y-axis, you will highlight this.
Okay. Edit. X-axis will include, is it in B?
So x-axis will be this
Okay.
column. Y-axis will be the first column. Okay. Excuse me for a second.
Something like that.
Okay. Now, one thing I wanted to point out here is these are black, right? Now, remember in this case, short sales not allowed.
Mm.
So let's see what happens if you try to construct a portfolio with a return of 0.0250, but short selling is not allowed. So I'll type 0.025. I'll go to data solver. And this one is already for short selling not allowed. Right? Because you see greater than equal to 0. Now all we have to do is solve. Okay. This is not what I was expecting. Let me check again. Mean greater than equal to 0. H14 is equal to J14. F11, J11. I wrote down 0.025.
You need that second constraint in there.
The second constraint, this one. Oh, yes, I didn't include that one. Yes, of course. So that was probably for minimum variance portfolio. Okay. So add. Yeah, I didn't include even the return constraint. Push OK. And solve. This is what I expected. Solver could not find a feasible solution. Can you guess why? Solver is saying there is no such solution. There is no such portfolio. If short selling is not allowed, look at the returns of each of the assets. What do you see? And when short selling is not allowed, weight cannot be negative. So what does it mean? What will be the minimum return of the portfolio if short selling is not allowed? So you can only long. What would be the minimum return if short selling is not allowed? This one, right? Isn't that right? So if short selling is not allowed, then you cannot construct a portfolio with a return anything below this. Isn't that right? Because weights cannot be negative. If weights are negative, then yes, you can negatively weight some of this. Make the portfolio return lower. Isn't that right? Why you will want portfolio return lower? Because you want to reduce risk. But in this case, it is not feasible because we have to have positive weight, right? And 100%, remember? Even if we allocate 100% in this, because if we allocate 100% or any percent in any of the remaining, returns will just increase, right? So that is what I wanted to show you. That's the reason you don't have returns anything below 0.05, actually 0.0337 after this. Okay. These boxes are, these cells are empty. Now, and for the same reason, when you plot these two, so go ahead and highlight these two columns, insert, recommended chart. And now you see Excel was able to pick up what we want, right? Because we already showed Excel the way. Did you also get the same suggestion from Excel? The same chart?
Yeah.
Yeah, okay, very good. So we only have the efficient frontier, right? This is our MPP. We only have the efficient frontier. We don't have the full MB frontier. Okay. Okay, now, can I move on?
Yeah.
Okay. Now in this, this was our optimal portfolio formula, right? I already discussed this. Now I want to calculate just once. You already know how to calculate, how to construct or find weights of an optimal portfolio, given these values of lambda, right? I deleted one just to show you one more time. So I will enter 7. This is the risk aversion coefficient. Go to data, solver, reset everything. Now, because it is optimal, first of all, our objective function is this. And we want to maximize, right?
Yeah.
Because it's utility. Variables don't change. Now add constraints. The only constraint is the weights need to sum to 1, right? So these are the weights equal to 1, right? And push OK. Uncheck this box. So we are telling solver, find out the portfolio that will optimize my utility function. The only constraint we have is the portfolio has to be fully invested. So happen.
The max, I mean.
Yeah.
Is it the maximum? I mean,
Yes, we should have maximum function. Let's see, let's look at it again. So G7 max F11 G11 subject to the constraint. See. Solver, reset everything. So this is our objective function. We want to maximize. Changing variable. Did you also get an error message?
Yes.
Select this, subject to the constraint. This equal to, did I choose equal to? Okay. Push OK. Uncheck. So, let's see what is wrong. I have this one correct. Oh, I don't have a formula here for some regions. Okay, let's type this formula. Can we copy paste? Let's see. Save some time. Oh, you lost all the formulas somehow. Okay, let's type it. SQRT, comma, MMULT, MMULT. These are the weights, comma, data. These are our covariances. Close. Transpose. Come back to this one. These are our weights. Close, close, close. Enter. Did we, no, this formula is here. We only lost this one, right? What about these ones? Yeah, these formulas are valid. Now let's try. Solver again. One, right? Did it work for you?
If I'm swimming from, if you.
So, yeah, so this is the only formula I can lost. SQRT, MMULT, MMULT. This, comma, data. These. Those. Those.
Yes, this work.
Those. Okay, is that all good?
Mostly,
So. Transpose. Let me have a look here. Name. Oh. This should be this one. Yeah, so we're going to check that and then close 3 times. Yeah, and then enter parentheses once, twice, and then hit enter.
You see. I feel like you can.
No, you got it. Okay, let me see. Okay. Let me do it from afresh, okay?
mhm.
Right?
This one.
This should be function.
Shift?
Shift. and
No,
this-
no, that's caps. This one.
And you. Is go to data.
me try this. Okay.
This type. This goes. Okay. Then go ahead and just solve, see if you get to the right weights. So you're good.
Yeah.
You guys are good. Okay. So. Now. So you'll follow the same process, right?
Yes.
For all the other portfolios. Stop, Control C. Paste here. Now. What I'm going to do, I'm going to calculate utility. Utility is this formula again. So equal to our return minus our lambda times our standard deviation squared.
The return minus lambda. And this 15. This 15.
So, and then it will just pull down. Now here, if you remember, you copy pasted these from the efficient frontier Excel. Short set allow. Okay. These values you have already found here. But when you copy paste, make sure you copy paste only for this, not everything you have, right? So only for these and these, and for minimum variance. Now this one, we have to do some manual thing here now. So let's say I choose lambda of 7. And then I'm going to use lookup formula. Lookup. The first is lookup value. I want to look up this value. Comma, where do I want to find out? I want to find out here. So after I have found out, I want to print, meaning output, the utility function value from here, the corresponding, and close. For example, because it is 7, it printed 0.0488, right? If you enter, let's say 8, it will print 0.0467, right? Okay, now what we are going to do here, this is my mu, right? Equal to, this will come from here, this mu. Okay. Now, this will be equal to lookup. I want to find out this value again, comma. I want to find out for this portfolio, meaning the portfolio that has lambda of 8, what was the weight in corp, right? So first, I want to find out this value in this column. I will lock this, comma. I want to find out the weight of corporate one, corresponding, close.
Oh, no, it's not that. Sorry.
Yeah, no, you're good. If it is too small, you can also look up here.
For the indifference.
So indifference means
It is 0. I did it and I got 0.04.
6, 7.
Look up T25.
Let me see, if you double click on it, it actually shows 0. So, so this one. Fine. Let's see if this changes. If you do 8. Yeah. So as you change the value, different numbers are plotted here.
Mm.
Now, this one should be this mu, and then this formula you can type from here.
So look up.
You're done, just pull across up to T-bone and see if the weights are being printed correctly or retrieved correctly. Remember to lock the first column, right? L15 to L20.
Yes.
Okay, and then you'll pull across. Why didn't my work? Me? What do you
You have
think?
to lock the T25.
I didn't log the T25. Thank you very much. Now, I will just pull down this, right?
Yes.
Okay. So, and then here, one more thing. This will be my utility. Log this. Plus this, log this, times my standard deviation. Square. So that was my optimal portfolio. I'm adjusting this with the standard deviation of our efficient frontier portfolios. That's all I'm doing. Okay. Okay. So pull down up to the last one without formatting. And if you change it to 7, is that what you get? If you change this number to 7, you get these numbers? I think it's good.
At the same number you have.
You don't?
Oh, I know why, sorry.
Okay, no, you're good. Rick?
I feel behind.
You feel 3 high? Let's see.
Yeah, this, I'm still with this one.
Oh, okay, so let's see. What happened here? Previously just pressing control what, right, for this formula?
What? Yeah.
Pressing. Okay. Take out. Control, option,
Which one?
if I want to. Yes, it is. T. And then ULT. They're my weights. I don't know what happened. I couldn't find out the problem there. Sometimes it is just easiest to start afresh.
So. Include these ones.
Okay. Yeah, finish that formula, yeah, you see that formula is typed in. Do not lock this. The standard deviation. This is standard deviation
And next one, right?
and raised to the power 2.
So I got the.
Is that right?
Yeah, all the way, yeah.
This one.
Mhm.
1-0.
Yeah.
So, for this one.
So,
Full across.
yeah, no, not pull across,
Mm,
pull down from these two formulas.
this one.
Yeah. Just one. Yeah. Looks good.
This number is.
Just that one.
Yeah. And then we have. And then and start this to be like your way it's gonna look in, so just click on.
These. Close it. I'm gonna lock them, right?
Nothing. Good issue.
Yeah, you're good.
Zero. Are you able to get these values, the one you're asking for? The variables.
Is yours different?
What is yours?
Something like. Yours.
What is it? If you double click on that side.
Oh.
You just. As soon as you. Yeah. Okay, you're. You can track.
Ah, they're there.
And then, okay.
here. YouTube.
It should.
Yeah, that's easier. It's 27. Yeah, so then I'll take off here. You can drag that down. That's it? Yeah. Thanks.
Everyone is good?
Yes.
Yes. Okay. So. Now what we are going to do is. As before, highlight this. Insert. Recommended chart. Recommended chart. Select data. Select data, edit. And the x-axis value should be this sigma. The y-axis value should be this mu. Okay. This is not how it should look like. Something is wrong again. The right numbers.
Is the 1.0631 throwing off
Which one?
the?
This one?
Yeah, is that one throwing it off?
Let's see, oh yeah, this number is wrong.
I just did a lookup to the 7 up
Oh,
top.
it
It's that.
doesn't have formulas. So somehow we lost formulas. We lost this MMAP formula somehow. So fortunately, we have to type this.
Okay.
Yeah, so this we can just type once, SQRT. So that was our formula previously too, right? Our issue previously. Good eye, Preston. I type this formula and pull down. You can ignore the curly brackets.
Okay. Mm. The M15, you're gonna pull it down?
Yeah. So after you enter this formula,
Yeah,
pull it down.
it's the, after the last MMULT. After the last MMULT over there, the formula. Look at the formula up.
Here. In the formula.
After the last MMULT.
So show me there.
After the last MMULT.
Mhm.
You can put it down.
Oh, yeah, go ahead, comma. But you cannot, you mean?
It's 15.
No, delete M15. Now try to select again. No, the other way, the weights, yeah,
Okay.
up to Q15, comma. Go to the data worksheet. Yeah, and then choose the covariances. Yeah, lock everything. Close. Transpose. Transpose type fully. Write the weights again. So if you cannot select clearly, just select any cell and then move up. And then move up. If you, yeah, and then,
Okay.
yeah, and then try to shift. And then shift. Until you have Q15.
Q15 again. Okay.
Close, close, close. Enter and pull down that formula, okay?
Okay, from here.
Go back, yeah, and pull down. Yeah, and then copy just one cell from there. Copy, Control C,
Okay, sir.
and then paste in
Yeah.
that sigma as a formula,
Yeah.
and then pull down as a formula fx. Yeah, and then pull down. Yeah. Actually pull down all the way without formatting. Okay. And enter 0 here. No, first value, yeah, enter 0. There you go. Okay.
Thank you.
Yeah. So, yeah, so pull down to this and enter 0 here. Now our chart should work. So. Okay, now highlight up to this. Insert recommended chart. Okay, that looks good. Okay. We just have to now switch the rows and columns. The axis, I mean. This should be our X. This should be our Y. Push OK. Okay. Now, if these two are not connected, go to select data again. Hidden and empty cells. Connect. Push OK. Okay. Now, to plot our optimal portfolio, all we have to do is excuse me. Select or highlight this and Control C. That means you are copying. Click on the chart and Control V, just paste on it. Okay. So. So this is what we did, right? This is meaning the chart in our two asset portfolio, but I did not show you all the calculations of utility and how to look up, right? Last class. So these are very, very useful Excel functions, okay? Even if you do not end up doing exactly this exercise, you will use these Excel functions. Now, as you can expect, as risk aversion coefficient increases, for example, let's say I type 10, it will slide down, right? It meaning the optimal portfolio. Now, I had a plan to cover another chapter, okay? Because we have covered only 2 chapters. We are behind by 1 week, actually. So what we can do, take 5 minutes break. We'll just do a little bit of Bloomberg activity. And then we'll skip the chart, the new chapter, the other chapter I plan to cover. And I'll include that in the future exam.
So we still have the exam next week.
You will still have exam next week. Yes, but based on only 2 chapters.
The Excel or?
Hmm?
So
It's on Excel.
So exam, I will give you some information on the D12, what type of questions. It will be multiple choice, both multiple choice and Excel questions.
So we have to bring our laptop to do the exam? or-
Yes, you will need your laptop. I will give you blank Excel. Yeah. There will be multiple choice questions from theory, like you have seen in other classes. For example, multiple choice meaning there will be multiple answers and you have to choose, right? So yeah, these will be related to theory. You guys have already taken my class, you know. And so go over the slides, the chapters from the textbook. And there may be also some short theory questions. For example, I may ask you contrast efficient frontier with minimum variance, mean variance frontier, which I discussed also in the class, right? Or define shortfall probability. I discussed in previous chapter. So as long as you go over the slides and relevant parts of the textbook, you should be good. Math-wise, do all the homework, do all the Excel from scratch, start from like an empty template, like I uploaded on D12, and try to replicate. Any questions?
Okay, so the homework one, the Excel, so you don't provide the data, so you just only give us the price, the day of the stock, so we have to look for the log. I
So,
need the homework.
you mean the previous homework?
No, this homework, the new one.
Or the new one? I will change the deadline. So
I mean like, but do you have the data tab like this one you have?
whether the homework will be like this?
No, the data tab. Or we have to look for the log by ourselves, right?
Yeah. So log, you mean you have to, are you asking, do you have to calculate this?
No, I mean the data, the table of the, yeah, yes, that's one, the mu something, yes.
Yeah, you have to calculate all of this.
Oh, okay.
Yeah. So Excel, I mean, you can already probably download the homework, right?
Yeah, I already see it.
The homework is. So you will get this,
Yes. Yes.
and I have made sure I have changed the layout so that you just cannot copy paste. Okay? So don't copy paste, don't, try to do it by yourself individually, and if you need help, you can sit together and discuss. But do it yourself, it will,
Will I have the same question in the exam, like in the example?
homework,
Yeah.
yeah, same numbers.
Homework. The exam question similar to this one?
There will be a question related to this. I probably will not ask you to do everything from scratch because of the time constraint. But there, I mean, yeah, but I will ask you to some specific calculations. For example, find out the optimal portfolio weights, or find out the portfolio weights with a return like the equal to this, something like that, some part of this. Okay,
Sorry, but this table is on the homework too, or we have to calculate it?
this one,
Yeah, the one you're showing right now.
yeah, these are already there for you.
It's there for us, right?
Yeah, this is the homework file.
Yeah.
Yeah, this is the homework file. You have to just complete this.
Yeah, that's one I know.
Yeah, and you have to complete this.
Thank you.
Exactly the same, just different assets.
Yeah.
5 asset, 5, yeah, 5 asset here too. So, yeah, let's meet in the Bloomberg terminal in after, let's say, 5 minutes. Okay.
So whatever I want to discover. Most everything, the numbers were not similar to that one. If you have questions. This is your. We allow a piece of note? during the
Yeah,
exam?
yeah.
Okay, that's
Make
what.
sure you have your formula sheet.
The what?
Make sure you have a formula sheet.
Oh, yeah, formula sheet, okay,
Yeah.
I thought it was just a regular note, but okay.
Yeah, just formulas. You
Just
cannot
formula,
have
okay.
anything else.
Yeah.
Yeah. But because you will need all these formulas, right? How to calculate utility. Yeah. So tell me again, what happened when you try to run solver?
We'll say.
No, you're fine.
Not this one, changing to this one. So.
Okay. Okay, let's me check. Now, you were saying here. Are you trying to solve for short sum allowed or short sum not allowed? Short sum allowed.
Yeah.
So then you cannot have the first constraint. You cannot, right? You will use that constraint. This is the constraint. F11 greater than equal to 0. Delete that one. Now you have H40 to J40. So, but you are missing H15. So go ahead and delete that too. Yeah, you can enter also separately. That also works. Okay. But then, yeah, H14 to H15.
This one and this to this one.
Yeah, there you go. And then, yeah, just solve. Push OK.
So so these are the this is the example I posted, right? Okay, so let's see what happened here. Yeah, so we actually missed this standard deviation formula, remember I mentioned? So you have to type this.
Deleted.
So go ahead and try to solve, for example, if you try to solve point 275 now. This one, right? So. Okay,
Yeah, same time.
you should get, right?
Yeah.
So this was the issue, and you also have to type the standard deviation formula here. I think everywhere, somehow this formula was lost. Okay, so you have to type everywhere. The formula, everywhere meaning you just type once, pull down. Type once and pull down, right? Similarly here, I think the same issue. We lost. Oh, you followed me there. So yeah, you followed me there too. But here it was the issue, yeah. Yeah, oh.